Radians and degrees both measure rotation, but they use different units. The SAT expects you to switch fluently between them. This lesson covers the conversion factors, a few quick examples, arc length in radians, and the memory angles you should know cold. We will also talk about the classic mistake, multiplying by the wrong fraction. Radians measure angle by arc length on the unit circle. Degrees slice the circle into 360 equal parts. Both are fine, but you must not mix them silently. When a problem says theta equals 5p over 6, hear radians first, then convert if the answer choices speak in degrees. The bridge equation is pi radians equals 180 degrees. That single fact generates every conversion. To convert degrees to radians, multiply by pi over 180. Degrees are bigger, so you scale down by pi over 180. To convert radians to degrees, multiply by 180 over pi. Radians are smaller, so you scale up by 180 over pi. Common mistake using pi over 180 when you meant 180 over pi or the opposite. Say the words out loud before you multiply. Easy example. Convert 60 degrees to radians. Multiply 60 by pi over 180. 60 over 180 is 1/3, so you get pi over 3 radians. That matches the key table. 60 degrees is pi over 3 radians. Medium example. Convert 5 pa over 6 radians to degrees. Multiply by 180 over pi. The pi cancels. 5/6 of 180 is 150, so you get 150 degrees. And notice that 5 pi over 6 is in the second quadrant, so 150 degrees makes sense. If you ever multiply by pi over 180 twice by accident, pause and ask which direction you want. Radians to degrees or the reverse. A quick mental check. Radians look like pi times a small fraction for common angles, while degrees are usually whole numbers under 360. Now we connect radians to arc length, where the radian measure finally pays off in a one-step formula. Harder application. Arc length when the angle is measured in radians. The formula is S equals r theta, where theta must be in radians. Suppose radius is 7 and theta is pi over 4 radians. Multiply 7 by pi over 4 to get 7 pi over 4 units of arc length. If the problem gave degrees instead, convert first, then use S equals r theta. Mixing units is another common failure point. SAT tip, memorize key angles. 30 degrees is pi over 6, 45 is pi over 4, 60 is pi over 3. 90 degrees is pi over 2, 180 is pi, 1 full turn is 2 pi radians. Calculator note. If you are on a handheld calculator, match rad mode to radian problems and DG mode to degree problems. Wrong mode is a classic mistake. When a problem mixes radians and degrees in the same paragraph, convert everything to 1 unit before you compare or add angles. Sector area uses the same theta in radians, 1/2 r squared theta. That pairs naturally with arc length, so practice them together. In NovaMaths drills, repeat conversions until they feel like mental arithmetic. Not a formula hunt every single time. Recap, pi radians equals 180 degrees. Multiply degrees by pi over 180 to get radians. Multiply radians by 180 over pi to get degrees. For arc length, use S equals r theta with theta in radians. Memorize the key angles to save time. Practice more on NovaMaths.